Good morning everyone, my name is Anashavardhan. I am studying Srinivasa Ramanujan Institution of Technology in ECE department. Today I am telling about JFET bashing techniques. Subject name is Electronic Devices and Circuits. Subject code 23AC302. JFET bashing techniques in topics. Introduction to JFET bashing techniques. What is JFET? Importance of JFET. Biasing fixed method, self-biasing with source resistor, voltage divider biasing techniques, comparison of biasing techniques, practical consideration in biasing, summary of key points, conclusion. First, introduction to JFET biasing techniques. JFET biasing is essential to establish a proper operation point for the device. Proper biasing ensures the JFET operates in its desired region, typically the saturation region. This presentation covers common biasing techniques used in JFET biasing. This is a JFET biasing techniques in channel. Next, what is JFET? A JFET is a voltage controlled device used mainly for application purpose. It has a gate, drain, and source terminal with the gate controlling the current flow. Unlike BJTs, JFET operates primarily in deflection mode, requiring proper biasing. The N-channel has three regions: gate, drain, source has control the current flow. The P-channel has same gate, drain, source. Next, importance of biasing in JFETs. Biasing stabilizes the JFETs drain current against variations in temperature and device parameters. Proper biasing prevents cutoff or full conduction which could damage the device or distort signals. Consistent biasing improves the linearity and overall performances of the amplifier, and this is the linear operations. Larger output has same shape as input except that is inverted. Next, non-linear operation. Output voltage limited clickable saturation. Next, fixed bias method. The fixed bias method uses a resistor connected between the gate and the negative supply voltage. It is simple but sensitive to variations in device parameters, leading to less stability. Adjustment are necessary if the JFET's characteristics change over temperature or with the different devices. And the fixed biasing method, the signal is moving to JFET biasing techniques. The difference between ID and RS is VDS. Next, self bias. Biasing with the source resistor. Self bias involves a resistor connected in the source, providing negative feedback for stability. The gate is usually connected to ground, and the source resistor sets the bias point. This method offers improved stability over fixed bias, making it popular and practical applications. Next, voltage divider bias techniques. Voltage divider bias uses two resistors connected in a voltage divider network to the gate. It provides excellent stabilization of the drain current against variations in parameters. This technique is widely used in amplifier circuits due to its high stability and predictability. On this diagram is current source bias. On this graph is characteristics of voltage divider biasing techniques. X-axis is VDE, VDS and Y-axis is ID. The Q1, Q2 are same. The Q1 the Q1 of IDSS is maximum and Q2 of IDSS is minimum. Next, comparison of biasing techniques. Fixed bias is simple but least stable, suitable for low precision applications. Self bias offers better stability and is easier to implement than fixed bias. Voltage divider bias provides the highest stability and is ideal for high performance circuits. And this is an JFET amplifier and its AC equivalent circuit. And these both diagrams but in different bays RO parallel to R1. Next, practical considerations in biasing. Selecting appropriate resistor values is crucial for setting the desired bias point. Overrating of resistors should match the current and voltage levels in the circuit. Testing and adjustment biasing components ensure optimal performance of the JFET. And this is a practical consideration in biasing. To apply the KVL for the diagram, to gate source terminal minus VG minus VGS equal to 0, VGS equal to minus VG. Since JFET has infinite input impedance, therefore Ig equal to 0. Since Ig equal to 0, that means voltage drop across R1 is 0, VR1 equal to 0. Just a summary of key points. Biasing techniques are vital for controlling the operating point of a JFET. Voltage divider bias offers the best stability and is most commonly used in practical circuits. Understanding the advantages and limitations of each method helps in designing effective JFET amplifiers. And this is the diagram of summary key points. To conclude it, proper biasing ensures reliable and predictable operation of JFET based circuit. Selecting of biasing techniques depends on stability requirements and circuit complexity. Mastery of JFET biasing techniques is essential for designing efficient and stable electronic systems. And this is a diagram for FET and feedback bias circuit. And thank you.